In today's video, we will be discussing the class 12th physics topic electric charges and electric fields. An electric charge is an intrinsic property of matter which gives rise to electric force between various objects. There are two charges, positive and negative. When there is a loss of an electron, it is coined as a positive charge, and when there is a gain in an electron, it is called a negative charge. Likewise, like charges repel each other and unlike charges attract each other. And now coming to electric fields, an electric field is a physical field that surrounds electrically charged particles and acts as an attractor or repellent to all other charged particles in the vicinity. Now let's discuss some important concepts that come under electric charges and fields. 1. Conductors and insulators. Any material that permits electricity to flow through it is known as a conductor. On the contrary, any material that does not support the free flow of electricity is known as an insulator. Further, conductors possess some electrical charge, electrons, that are comparatively freely movable. 2. The properties of electric charge. As we already know, there are two types of charges present, positive and negative. However, their presence in a material tends to cancel each other. Now, point charges are determined when the charge size is very small compared to the distance between them. Therefore, all the charges are assumed to be confined to one point in space. There are three fundamental properties of charge, and they are: additivity of charge. According to the definition of additive charges, if there are n number of charges present in a body, the total charge present will be calculated as the algebraic sum of the individual charges. Conservation of charge. The conservation of charge defines that the total charge in an electric body never gets altered or changed. The total charge of a body is always conserved, while the amount of positive charge gets deducted from the total negative charge on a point in space. And quantization of charge. The quantization of charge indicates that any charged particle can possess the charge equal to some integral number of e. The next topic is Coulomb's law. Coulomb's law states that when two charged bodies are present, the force of attraction or the force of repulsion is directly proportional to the product of their magnitude and varied inversely to the square of the distance between them. According to the principle of superposition, it is proved that a force applied on any charge because of several other charges is the vector sum of all the forces on that one charge due to the presence of other charges. However, the individual charges remain unaffected by the presence of any other charge. Now let's discuss some of the general properties of electric field lines, and they are: two lines never cross each other. These electric field lines start on the positive charge and end on the negative charge. Electrostatic field lines do not form any closed loop. Next topic is electric flux. Electric flux is the total number of electric lines passing through a confined area in the same unit of time. On the contrary, in the case of liquid, there is no physically observable quantity of the similar. The last topic for the day is Gauss's law. According to Gauss's law, the enclosed electric charge directly proportionately affects the net flow of an electric field on a closed surface. The area of the surface in a plane perpendicular to the electric field times the area of the field passing electric field is how the electric flux is calculated. The net flux of an electric field through a surface, divided by the enclosed charge, should equal a further explanation of Gauss's law. To read more about electric charges and field, check out the link in the description, and for exciting content and relevant information do check out our website at www.getmyuni.com.